Howdy folks! In this video, we are going to be doing 5 examples on solving trigonometric equations. Pay attention to each example because they have been carefully chosen to bring up certain techniques and things to look out for. Now before we begin, notice that we want all solutions to be between 0 to 2 pi, including 0 but not including 2 pi. Let's begin. Example 1 says tangent of 3x equals root 3. Now before we begin, if we want our solutions to be between 0 and 2 pi, but this problem says 3x, we are going to multiply 0 to 2 pi by 3. So we want to work with angles between 0 and 6 pi. So we think in the unit circle, where on the unit circle will there be a tangent value of root 3? Positive root 3, that is. Well, there are 2 places on the unit circle. One place is right over here, right at pi over 3, or 60 degrees. The other place is right over here at 240 degrees, or 4 pi over 3. Those are the only 2 locations for which the tangent value is root 3. So we're going to set 3x equal to pi over 3 and 4 pi over 3. However, those 2 angles are only in the first rotation of the unit circle. But according to our new interval here, we want 3x to be between 0 and 6 pi, which means that we want to cover 6 pi, which is 3 rotations around the circle. So if there's a 3 in front of the x here, that means that you want to go around the circle 3 times, because 0 to 6 pi is 3 rotations of the unit circle. So you have to keep listing values that are coterminal, that's the correct term, coterminal with pi over 3 and 4 pi over 3. So you just simply add 2 pi to pi over 3, and you get 7 pi over 3. You add 2 pi to 4 pi over 3, and you get 10 pi over 3. Then you have to add 2 pi again for the third rotation. So that would be 15 pi over 3. Nope, that is not correct. Hold on. So you add another 2 pi to 7 pi over 3, which is 13 pi over 3. And then finally, the last angle is going to be 2 pi past 10 pi over 3, which is 16 pi over 3. So you have 6 values because we went around the unit circle 3 times, and each rotation around the unit circle gave us 2 solutions. So now you just divide everything by 3, and you get the solutions pi over 9, 4 pi over 9, 7 pi over 9, 10 pi over 9, 13 pi over 9, and 16 pi over 9. And those are all your solutions between 0 and 2 pi. Next example. This time we have sine of x over 2 equals root 3 over 2. So we're going to start off with the fact that our solutions have to be between 0 and 2 pi, which means that x over 2 is going to have to be between 0 and pi. All we did was divide everything in this inequality by 2. Alright, so x over 2 has to be between 0 and pi. That means that we only go half a rotation around the unit circle. So here's the unit circle, and we think to ourselves, where on the unit circle is the sine value root 3 over 2? And there are 2 places. One is over here at pi over 3, or 60 degrees. And the other location for which sine is is root 3 over 2 is here at 2 pi over 3. So this means that x over 2 equals to pi over 3 and 2 pi over 3. Notice that we only restrict ourselves to the half a rotation of the unit circle because x over 2 right here has to be between 0 and pi, so we only go from 0 to pi to get our answers. All right, and to end this, we are going to multiply everything by 2, and we have 2 pi over 3 and 4 pi over 3, and that is what we have for number 2. Number 3. This should look familiar. This is in quadratic form if we let u equal to cosine x. So what we have here is 2u squared plus u minus 1 equals 0. If this is factorable, then you factor. And it looks like it is factorable. 2u minus 1, u plus 1. So this gives us u equals 1/2 and u equals negative 1. Our goal, however, is to solve for x. So we substitute cosine x back in for u. And then we ask ourselves, where on the unit circle is cosine 1/2? And there are two places. Right over here at pi over 3, and right over here at 5 pi over 3. So in this place, in this half of the solutions, we have pi over 3 and 5 pi over 3. Okay, so here we ask ourselves, where on the unit circle is cosine equal to negative 1? And there's only one place, that's over here at pi. So here we have x equals pi, and so these are our solutions. Now you don't have to do the u substitution if you're able to just factor this with the cosine. And how would that look like? Well, that would just be 2 cosine x minus 1 cosine x plus 1. Okay? So if you're able to do this without u substitution, you certainly can. You certainly may. Okay, example 4. Now this example is a little bit different because I've got two trig functions going on here. So what should we do in a case like this? Well, almost always you're going to bring everything on one side. Now do not divide both sides by tangent x. If you do that, you are going to lose a solution somewhere along the way. Instead, subtract 3 tangent x on both sides. And here, our instinct is to factor. And indeed, that is what we should do here. Tangent x, parentheses, sine squared x minus 3, close parentheses, equals 0. So now, we are going to use the zero product property. We have tangent x equals 0 here, and we have sine squared x equals 3 over here. So now we have x equals, and you ask yourself, where on the unit circle is tangent 0? Well, here at 0 radians and here at pi radians. So our solution here is 0 to pi. Now on this side, you are going to square root both sides. So here you have plus or minus root 3. And so we ask ourselves, where on the unit circle is sine positive root 3 or negative root 3? Well, notice that root 3 is approximately (1.7). Sorry for the delay there. Root 3 is approximately 1.7. And you know that for sine, the greatest that it can be is 1, and the least that it can be is negative 1. Therefore, there is no solution that comes from this part. Okay? So that means that right here is our solution. X equals 0 and pi. Next problem. Example 5. Now we have another instance where we have two different trig functions and there's nothing we can factor. So the strategy here is to write everything in terms of one trig function. And conveniently, cosine squared x is the same as 1 minus sine squared x. And we want to do that because now everything is in terms of just one trig function. We distribute and rearrange some of the terms, and we have this. And now we have a quadratic again. Negative 2u squared plus 3u plus 2 equals 0. Many times, so we're letting u equal to sine x. Okay. Now, many times, I prefer to use have the quadratic term be positive. So we factor out a negative. This way, we can factor a little bit easier. So what do we have here? We have negative of 2u plus 1 times 2u minus 2. So then this breaks into u equals negative 1/2 and u equals 2. Now we substitute sine back in, and we ask ourselves, where on the unit circle is sine negative 1/2? And there are two places. Right over here at 7 pi over 6, and right over here at 11 pi over 6. So you need to know your unit circle values really well. You need to remember that the sine value refers to the y-coordinate. And if sine x here is negative 1/2, that means that you can only be in the third and fourth quadrants, because those are the only quadrants in which the y-coordinate is negative. Over here, we have sine x equals to u, and for the same reason as before, sine can never be greater than 1, so there is no solution here that comes from sine x equals 2. So our solutions are x equals 7 pi over 6 and 11 pi over 6. All right, hope these 5 examples are helpful to you as you do worksheet Trig 2, number 4.